Medical device engineers need to perform simulation early in the development cycle to better understand how their products will perform. For example, consider a medical inhaler where it's critical to know if the design will deliver the correct amount of medication in the proper way to the patient. Computational fluid dynamics, otherwise known as CFD or flow analysis, can help you achieve the right design. NX makes it easy to conduct flow analysis. In this example, you'll see a simple workflow for setting up a steady-state flow analysis for a medical inhaler, from preparing geometry to meshing and defining loads and boundary conditions, and finally to examining results. The first step of the process is to create the geometry representing the air volume inside the inhaler. The volume will span between the injector, which is the part attached to the pressurized medication cartridge, all the way to the breathing port. Using traditional CAE tools, creating this air volume would be tedious and time-consuming. However, NX greatly simplifies this task with analyst-oriented tools for geometry idealization, along with the full suite of NX modeling tools, including synchronous technology. The next step is to mesh the air volume. First, create mesh mating conditions between the bodies to make sure the meshes will connect. Then mesh the nozzle and air volumes. When creating the mesh, it's important to use an appropriate mesh size to capture the flow field through the regions of high variation in the injector nozzle. Finally, assign each mesh a material, such as air for the fluid volumes. Now that the mesh and fluid properties are defined, you can apply boundary conditions. Here, boundary conditions have already been applied at the injector inlet to represent the pressure release through the valve when the patient presses down on the pressurized canister. A second boundary condition represents ambient air conditions at the inhaler exit. To evaluate how effective the injector nozzle is at dispensing medication, you can use particle tracking. Injecting a certain number of particles at the injector inlet allows you to detect where these particles are discharged in the inhaler assembly. The analysis model is now complete and ready to solve. As the solver runs, you can monitor its progress and track convergence of the flow equations. NX delivers multiple out-of-the-box tools to efficiently examine your simulation results. First, review the velocity results set. This first contour plot shows that the gas jet is deflected downwards by the geometry of the discharge region. Other ways to view results include isosurface, or use streamlines to visualize the flow field. Finally, you can review the particle injection results to determine if the right amount of medication is being delivered to the patient. NX makes it easy for you to conduct flow analysis in medical devices or many other types of products involving fluid flow. NX delivers flow results through a fully integrated environment that allows you to quickly move from design to advanced CFD faster than traditional CAE tools.